Welcome student in a new video of multiple integral. In that multiple integral, the one part that is the change the order of integration. Sometimes in the given integration means double integration, by the given limits, evaluation of that double integration is difficult or impossible. In such case or in such cases, it is necessary to change the order of integration. Sometimes in the given double integration, here, suppose y limits are given inside. It means that we have to integrate with respect to y. But due to this integrand, it is very difficult to integrate with respect to y. But if we integrate this integrand with respect to x, it is very easy to evaluate. So in such case, it is necessary to change this y here and this x here. That is supposed to be a change the order of integration. Now problem is that how to change the order of integration. So there are some steps which you have to remember to change the order of integration. So step number 1, to change the order of integration, first draw the rough sketch of the region of integration. Means by the given double integration, means for example I equal to, here the limits given. So by these equations you find the region of integration. Find out which strip is given. Means these limits inside and this is a constant. So by using that I can decide which strip is a constant. By example it will be more clear. So find out which strip is given by the given limits of integration. Then change that strip. It means that if vertical strip is given, change that strip in that region and take horizontal. So that is, if given strip is horizontal, then take vertical strip and vice versa. It means that if given strip is vertical, then take horizontal strip. And by that new strip, you evaluate the integral. It means that by that strip, you decide the limits and then evaluation will be very easy as compared to this one. So let's consider some example on it. So here is an example. Evaluate I integration 0 to infinity, inner integration 0 to x e raised to minus x square by y into dx dy by changing the order of integration. So here whatever there, we have to change the order of integration. Why? Because example itself contains change the order of integration. Means easy or difficult, we have to change the order of integration. But suppose the same example is just evaluate, then can we solve directly? Let's see here. So here inner integral contains x, means we have to integrate with respect to y. And what is there y? Y is minus x square by y e raised to. It means that here integration of this is very difficult. But instead of that, if integration of this with respect to x, what is the derivative of this with respect to x? It is a minus 2x by y. And here 2 and y both are constant when we are taking with respect to x. So here I can adjust this one, and that is why integration with respect to x is easy. So here this example is just like a evaluate, then also it is necessary to change the order of integration. So how to solve this one? So solution given I equal to, I means integration. Here it is given, otherwise I will denote by I always. Integration 0 to x e raised to minus x square by y dx dy. Now I want to evaluate this by changing the order of integration. So what are the steps to change the order of integration? By the given limits you find the region of integration. So what are the given limits? Here limits are y equal to 0 to y equal to x and x equal to 0 to x equal to infinity. Note that here it contains x. It means that these are the limits of y and definitely outside the limits of x. Now how many equations are there? There are 4 equations, first, second, third and fourth. Out of these you just consider first equations which contains both. So there is only one equation which contains both. What is it? Y equal to x. It is a y equal to x. So draw this one. So here it is x axis, it is a y axis and this is a x equal to y or y equal to x. So here y varies and x constant. Given limits, y varies and x constant. X constant means that strip cut to x axis, means given strip is what? Vertical. So that vertical strip is from y equal to 0. What is y equal to 0? Means x axis. To y equal to x means this line. X equal to 0 means y axis and x is infinity. So what is the region of integration here? That strip is on y equal to 0 means here to here. This is the boundary of y and x equal to 0 to infinity. So what is the region of integration here? This is the region of integration. Now change the order of integration. It means that change that strip. Vertical strip is now changed by horizontal strip. So take horizontal strip. Here you write the region of integration is as shown in figure. And here I want to take now strip horizontal. So this is your strip up to, it is up to end. End means what? X equal to infinity. And therefore, when we extend this strip, it cut to what? It cut to y axis, means y constant and x varies. So you write here limits are, it cut to, when we extend it, it cut to y axis, means y constant and x varies from x equal to, you decide, and y constant. So x varies. So what is this one? What is the equation of this one? X equal to y. X equal to y. So what is the last means of this one? It is up to infinity. And what about y limits on axis? So y starting here 0 to where it ends? Here ends up to infinity. So here y equal to 0 to y equal to infinity. So these are the limits of y. And once we have the new limits, then it is very easy. I equal to integration 0 to infinity, inner integration y to infinity, and x e raised to minus x square by y dx dy. Now note that inner integral contains y, means integrate with respect to x, y constant. So you take y constant. So y integration y to infinity, x e raised to minus x square by y dx, and y constant, it is outside. So as we know the standard result, what is that result? Integration of e raised to f of x, if derivative present there, then it is equal to e raised to f of x. So by using this I will try to obtain their derivative of the function. So what is it? It is the integration 0 to infinity. Note that here integration y to infinity e raised to minus x square y. What is the derivative of this one? It is with respect to x, it is a minus 2x by y. Note that here only x active, that is why minus 2 and this y constant. So I will adjust that thing. How? So here I will write it minus 2x by y. So what is the additional I am taking? Only x is there. So I am taking minus 2 by y. So same thing I will write outside of that integral. It is a y by minus 2. And outside dy as it is. Note that now e raised to f of x and derivative present, and it is with respect to x. So I am getting, by using this standard integration formula, I am getting integration 0 to infinity, this y by minus 2 as it is outside, and here I am getting e raised to f of x, means minus x square by y, lower limit y, upper limit infinity into dy. So upper limit minus lower limit. So this minus y by 2 as it is, and here I am getting upper limit minus lower limit. So upper limit is infinity, e raised to minus infinity is a 0, minus lower limit is y. So x replaced by y. So I am getting minus y square by y. So I am getting e raised to minus y and dy as it is. It means that this we have to integrate with respect to y, simplified. So I am getting I 1 by 2 constant, this minus sign we can adjust inside. So I am getting y into e raised to minus y dy. Now here u into v rule, continue uv rule. What is that continue uv rule? It is the integration of u into v dx equal to first constant integration of second minus derivative of first integration of second plus derivative increases by 1 and integration increases by 1, alternate sign. So u v1, it means that it is a integration. So this integration increases by 1 and here the derivative increases by 1. So what I am getting? I equal to 1 by 2. So u is y here. So first constant integration of second, keep in bracket, do not adjust sign because we want a next integration and derivatives also. So minus sign, alternate sign, derivative of first bracket it is 1. Integration of this I am getting e raised to minus y by minus y, but already minus 1, so I am getting plus 1. Now next derivative of 1, it is 0 and that is why here it finish 0 to infinity. Upper limit minus lower limit. Don't forget standard value e raised to minus infinity is 0 and that is why I am getting here upper limit is e raised to minus infinity. So both contains here, so that is why I am getting here 0 minus lower limit y is 0, I am getting 0 here and here minus e raised to 0, it is 1, so I am getting 1. So simplify, so I am getting I equal to 1 by 2, which is your required answer, means required integral value. Now this is the example. Evaluate integration 0 to 1 dx, inner integral 1 to infinity e raised to minus y into y raised to x log y dy. So what is the meaning of this first integration? See there, normally in other double integration it contains any one variable, but if both are constant, so it is not easy to decide which is the first one. In such sequence you always consider the given sequence. Suppose here dx dy, it means that we have to integrate first with respect to x, means these are the limits of x and then y. Or if suppose the dy and the dx, it means that first you have to integrate with respect to y and then dx, means these are the limits of y. Or sometimes they may provide like this, it means that here this with respect to y, so it is more easy. So we know this we have to integrate with respect to y and remaining with respect to x. Now see there, this integrand we have to integrate with respect to y. How many y? 1, 2, 3 terms, 3 functions with multiply. But instead of, if suppose it is with respect to x first, what is the integration of dx? It is simply x. So which is easy one? This one or this one? So x is easy and that is why first integrate with respect to x is easy thing. And here it is necessary to change the order of integration. So let's start solution. So answer here, let I equal to 0 to integration 0 to 1 dx inner integration 1 to infinity e raised to minus y y raised to x into log y dy. You just go with stepwise. So what are the steps? It is necessary to change the order of integration. Now by the given limits. So what are the given limits? So here limits are. So definitely with respect to y means these are the limits of y. So y equal to 1 to y equal to infinity and remaining x equal to 0 to x equal to 1. It means that here y varies and x constant, means given strip is vertical. We have to change, we have to take horizontal. So first you find the region of integration. So here 4 equations, y equal to 1, y equal to infinity, x equal to 1. So find the region of integration. So here is x-axis, here y-axis, here x equal to 1 means this line, x equal to 1, and this line means y equal to 1. So this line is y equal to 1, this line is x equal to 1. Here given strip is vertical, y equal to 1 to infinity, up to infinity, and x equal to 0 to x equal to 1. So definitely here 0, 0, and here x equal to 1, means 1 comma 0. So 1 to infinity and 0 to 1, x equal to 0 to 1 on this. It means that this is the region of integration up to infinity. Note that here this region from y equal to 1 to infinity, up to infinity, upper part of y is infinity. Okay, now we have to change that strip. Given strip is vertical, now we have to take horizontal. So this is your horizontal step. So once we get a region of integration, we know you find all boundary points and boundary equations. What is this boundary? It is 1, 1. It is a x equal to 0, y is 1. Here equation of this line, y axis, it is x equal to 0. And here x equal to 1. So note that here, the region of integration is as shown in figure. So given strip is vertical. To change the order of integration, take horizontal strip. Therefore, limits are. Note that here horizontal strip. So it cut to y-axis. If we extend, it cut to y-axis. And therefore, y constant and x varies. So x equal to x varies and y constant. So how to find values of x? By equation. So x equal to 0 to x equal to 1. And y equal to boundary points on y-axis. Starting point is y equal to 1, 2. What is the end point? Infinity. So these are the limits of y. And therefore I am getting here I equal to integration 1 to infinity. Here limits of x 0 to 1. Note that these are the limits of x. So only x inside. So what is x inside? How many contains x? This and this one. Only inside. So y raised to x into dx. So these are the limits of x only inside x and remaining outside. So this we already taken. It means that e raised to minus y log y dy. So integrate it. It's very easy now. So what is the integration of this with respect to x? Note that it is just like a raised to x because here a constant, here y constant for this. And that is why what is the integration of it? I equal to integration 1 to infinity. What is the integration with respect to x? It is a y raised to x upon log y because y is a constant here. 0 to 1 remaining as it is e raised to minus y log y dy. Upper limit is what? 1. Integration 1 to infinity. Here upper limit is 1. So y raised to 1. X replaced by upper limit minus x replaced by lower limit. So I am getting y upon log y minus lower limit is what? 0. Y raised to 0 is 1 upon log y. Remaining as it is. So simplify it. I equal to integration 1 to infinity. In bracket I am getting y minus 1 upon log y. Outside e raised to minus y log y. So log y get cancelled. So what is remaining? Very simple thing I am getting. So it is a integration from 1 to infinity y minus 1 into e raised to minus y dy. Note that even though here double integration, one by one we have to solve just like a single integral. So here I am getting a single integration with respect to y now. So how to integrate it? U into v rule. Continue. What is it? uv dx. First constant integration of second minus the derivative of u integration of v plus it means that derivative and integration increases with alternate sign. So here u is this, v is this one. So I am getting I equal to first constant means y minus 1 constant integration of second, do not adjust sign, keep in bracket minus derivative of this one with respect to y. It is 1 into integration of this one with respect to y. So e raised to minus y by minus 1, already minus 1. So I am getting plus 1. Next derivative of this is 0. So finish 1 to infinity. Upper limit minus lower limit. Again don't forget here e raised to minus infinity is a 0. So I am getting upper limit e raised to minus infinity. So here and here I am getting 0. So upper limit minus now lower limit. So y replaced by 1. So y minus 1 it is a 0 minus here e raised to minus 1. So e raised to minus 1. So simplify it. So what is it? I equal to this minus minus plus e raised to minus 1. It means that I equal to 1 by e, which is your required answer. So next example, evaluate integration 0 to 1, inner integration 0 to under root of 1 minus y square cos inverse x dx dy upon 1 minus x square minus y square into 1 minus x square whole raised to half by changing the order of integration. So here the example contains changing the order of integration. It means that it is necessary to change the order of integration. But again you check, can we evaluate directly also? Let's see here. Inner integral contains y, means we have to integrate with respect to x. How many x there? Cos inverse x, here x and here x. But if we compare y, how many y? So here only one term of y, and here also it is under root, because due to this half raised to half means under root, and here I am getting 1 minus y square. Note that 1 minus x square is a constant when we are taking with respect to y. So it is just like a 1 upon under root of a square minus y square, and it is very easy to evaluate with respect to y. So that is why here necessary to change the order of integration, even though it is just evaluate. So to change the order of integration, steps are very simple. By the given limits, you decide the region of integration, you find out which strip is given and change that strip, and by the new strip you decide the limits and evaluate. So start it. Let I equal to integration 0 to 1, inner integration 0 to under root of 1 minus y square, and integrand is cos inverse x dx dy upon raised to half. So that I will take here under root. So under root of 1 minus x square minus y square first term, and second is 1 minus x square. So given limits are, so here limits are. So what are the limits? Here it contains y, means these are the limits of x. So x equal to 0 to x equal to under root of 1 minus y square, whatever they are, and remaining y equal to 0 to y equal to 1. So there are 4 equations. How many contains both variable? So there is one equation contains both. Simplify this and or try to find the region of integration. So what is it? So x equal to under root of 1 minus y square. This implies that x square equal to 1 minus y square, and this implies that x square plus y square equal to 1. So I am getting one circle having center at 0, 0 and radius is 1. So draw it and find the region of integration by all limits. So here is the region of integration. X is here, y axis, and here it is the circle x square plus y square equal to 1. Center at 0, 0, radius is 1. Now x equal to 0 means y axis, y equal to 0 means x axis. So here x varies and y constant, means given strip is what? Horizontal. It cut to y axis means horizontal. Given strip from x equal to 0 to circle. So like this. And y equal to 0 to this point 1. So here it is a 0 comma 1. So here it is a 1 comma 0. So here region of integration is this by the given strip. Note that. Once we get the region of integration, now we have to change the order of integration. But before to that, you see there how many boundaries of this region of integration? 3 boundaries are there. Write all equations, and now we have to change the order of integration. So take here vertical strip. Given strip is horizontal. So now take vertical strip. So like this. So right here the region of integration is as shown in figure. Given strip is horizontal. To change the order of integration, take vertical strip. Therefore limits are, so along the strip it cut to x-axis. It cut to x-axis means x constant and y varies. Y varies and x constant. So you write like this. So y varies from this equation to this equation. So what are the equations? Y equal to 0 to what is the value of this? Means equation. It is a y square equal to 1 minus x square. So what is the y? Y is under root of 1 minus x square, and x on the axis 0 to 1. So I am getting here limits 0 to 1. Now we have the new limits. So that is why I am getting I equal to, with the new limits 0 to 1, integration 0 to under root of 1 minus x square, and integrand same as it is, cos inverse x dx dy upon under root of 1 minus x square minus y square into 1 minus x square. Note that here inner integral contains x, means integrate with respect to y. So only y inside. So I equal to 0 to 1, only y inside. 0 to under root of 1 minus x square into dy upon under root of 1 minus x square minus y square, and remaining outside it is the cos inverse x dx upon under root of 1 minus x square. We know the formula, which is that integration dx upon or dy upon under root of a square minus x square, it is equal to sine inverse x by a. So I am getting here I equal to integration 0 to 1. It is a is what here? What is the a square? A square is 1 minus x square. So what is the a? Under root of 1 minus x square. Note this thing, and that is why I am getting here. It is a sine inverse x, means here y, by a. A is what? Under root of 1 minus x square. Lower limit 0, upper limit is 1 minus x square. So remaining as it is. So I am getting cos inverse x dx upon under root of 1 minus x square. So upper limit minus lower limit. So y replaced by upper limit minus y replaced by lower limit. So I am getting integration 0 to 1. Note that upper limit is under root 1 minus x square upon under root 1 minus x square. So I am getting here sine inverse 1 minus lower limit is 0. So y equal to 0. So I am getting sine inverse 0. Remaining as it is, cos inverse x dx upon under root of 1 minus x square. So I equal to, what is the standard values? What are the standard values? That is the sine pi by 2 equal to 1, means sine inverse 1 is pi by 2, and sine 0 equal to 0 means sine inverse 0 is 0. So I am getting pi by 2 minus 0 into cos inverse x dx upon under root of 1 minus x square. So pi by 2 is a constant, we can take outside. So I am getting simple. It is a pi by 2 integration 0 to 1 cos inverse x upon under root of 1 minus x square dx. Now put here, it is very simple. It is a simple integration because the derivative present. So put cos inverse x equal to t, differentiate. So I am getting minus 1 upon under root of 1 minus x square dx equal to dt. What about the limits? X to t. So when x equal to 0, cos inverse 0 is pi by 2 and cos inverse 1 is 0. So what I am getting? I equal to pi by 2 constant integration pi by 2 to 0 cos inverse x is a t, and remaining this one, it is nothing but minus dt. So I am getting t into minus dt. So that is why I am getting here minus, due to this minus, this integration change, or you can take this minus outside. So I am getting minus pi by 2 integration pi by 2 to 0 t dt. So what is the integration of t? It is a t square by 2. So I am getting I equal to minus pi by 2. It is a constant, and here t square by 2, lower limit is pi by 2, upper limit is 0. That is a minus pi by 4, because this 2 outside, upper limit is 0. So 0 minus square of this one, it will be a pi square by 4. So minus minus plus. So what is I? I is pi cube by 16, which is your required answer. Example, evaluate integration 0 to a, inner integration 0 to a minus under root of a square minus y square xy log x plus a upon x minus a whole square dx dy. So this is the integral, and these are the limits. So limit contains, inner limit contains y, means integrate with respect to x. So how many x are there? X, then log of x plus a upon x minus a. So 3x, but how many y? Only y. And what is the integration of y? It is a y square by 2, which is a easy one. So with respect to y is easy one. It means that we have to change the order of integration. Because given limits contains y, means integrate with respect to x is there. That we have to change, integrate with respect to y. For that we have to change these limits. How? The method is very simple. By the given limits, find the region of integration, find out which strip is given, change that step and decide the new limits and evaluate. So solution here. So let I equal to integration 0 to a inner integration 0 to a minus under root of a square minus y square. Integrand is xy log x plus a upon x minus a whole square dx dy. So given limits are here. What are the limits? Inner integral contains y means integration with respect to x. So x limits are x equal to 0 to x equal to a minus under root of a square minus y square, and remaining y equal to 0 to y equal to a. By these limits you find the region of integration. How? So there are four equations. Out of that, one equation contains both variables that you consider x equal to a minus under root of a square minus y square. This implies that x minus a equal to minus under root of a square minus y square. Take squaring of both sides, so I am getting x minus a whole square equal to minus square, it is a plus, and here I am getting a square minus y square, and therefore I am getting x minus a whole square plus y square equal to a square. So it is a circle of center a comma 0 and the radius is a. So draw or find the region of integration. So it is x-axis, y-axis, and here the circle with center at a comma 0 and radius is a, means this distance is what? A. Now you decide the given step, or by the given limits you decide the step and region of integration. How? So note that here. Given here x varies and y constant. Y constant, it means that it cut to y-axis, means given strip is horizontal from x equal to 0. So what is x equal to 0? It is the y-axis. And this is the circle. So what is the equation of this circle? It is a x minus a whole square plus y square equal to a square. Then y equal to 0 means x-axis, and y equal to a means there is a one line parallel to x-axis. It touched to the circle. So what is this line? This line is y equal to a. Now by the given limits, strip is horizontal from x equal to 0 to circle, x equal to 0 to circle, and y equal to 0 to y equal to a. So region of integration is this much. Once we get the region of integration, change the strip. So important part is what? Region of integration by the given information or limits. So this is the region of integration. How many boundaries of this? 3 boundaries. Write the equation of all boundaries. So here y equal to a, here the circle x minus a whole square plus y square equal to a square. And now to change the strip, so boundary points before to that 0 0, here this point is x equal to 0, y equal to a, and this point is a comma a. Now change the order of integration, means horizontal strip given, now change to vertical. So take a vertical strip now. Along this strip, when we extend it, it cut to x-axis, means x constant and y varies. So right here the region of integration is as shown in figure. Given strip is horizontal, so to change the order of integration, take vertical strip. Therefore limits are, so note that here when we extend that strip, it cut to x-axis, means x constant and y varies from y equal to equation to equation and on x-axis boundary points or x constant. So y varies from, so what is the equation of here and what is the equation of y here? So here at this, here what is the value of y from this? It is a y square equal to a square minus x minus a whole square, and what is a y? It is a under root of this. So here you write y equal to under root of a square minus x minus a square, means this is a lower limit to upper limit is y equal to a. And what about x on boundary points on x-axis? X equal to 0. So here the last point x equal to 0 to x equal to a. So these are the limits of y and x. So note the limits, how to take. Take a vertical strip, when we extend it, cut to x-axis, therefore x constant, y varies from equation to equation. So here is y, find the value of y by using equation. Here you find the value of y by using the equation. And once we get the limits of y, then the limits of x on x-axis means the boundary points, where curve start here and here ends. So I am getting these limits. Now you put these limits. So I equal to integration 0 to a, inner integration from under root of a square minus x minus a whole square to a. And what about the integrand? Integrand is here. Note that in exam need not to write this part. Directly you can consider. But here we are, for understanding I am going to write. So here inner integral contains x, means integrate with respect to y. So only y inside, remaining all outside. So let's see what it gives. So limits you put, and here only y. So it is very easy. Only y dy is inside, remaining all outside. That is x log x plus a upon x minus a whole square into dx. So what is the integration of y with respect to y? Just like a single integral, you solve it or evaluate it. It is a y square by 2. Lower limit and upper limit you put there. It is the under root of a square minus x minus a whole square to a, and remaining as it is, that is x log x plus a upon x minus a whole square into dx. So evaluate it, upper limit minus lower limit. You can take this 1 by 2 outside, 0 to a, upper limit it is a, so a square minus lower limit, so square of this one. So I am getting it is a square minus x minus a whole square, and remaining as it is, that is x log x plus a upon x minus a whole square dx. So simplify it. So what I am getting, a square minus a square get cancelled, and minus minus plus, so I am getting 1 by 2 outside, 0 to a, and here x minus a whole square remaining as it is, so x log of x plus a upon x minus a whole square dx. So note that this get cancelled. So it is simply single integration with respect to x. So what is it? I equal to 1 by 2 integration 0 to a x log x plus a into dx. So u into v rule, integration by parts. It is the integration of uv dx, first constant, integration of v minus integration of derivative of first into integration of second into dx. So here this is a u and this is a v. Getting I equal to, because LIATE, so logarithm is always first, so that is why it is u and this is v. So I am getting I equal to, note that here 1 by 2, it is outside. First constant means log of x plus a constant into integration of x is x square by 2, lower limit 0 to a minus integration 0 to a derivative of this one. So it is a 1 upon x plus a into integration of second, so x square by 2 into dx. So simplify it, it is a 1 by 2. So I equal to 1 by 2 is outside. Now upper limit a, so log a plus a, it is a 2a into a square by 2, and due to lower limit, because x is 0 now, it is 0 minus, so this I will take outside. So I will take here 1 by 2 integration 0 to a x square upon x plus a dx. How to evaluate this one? Note now here the adjustment. But before to that, simplify first part. So I am getting I equal to a square by 2 into half. I am getting a square by 4 log of 2a minus 1 by 2, 1 by 2, 1 by 4. So inside in the integral is x square minus a square, this adjustment, and plus a square, note the adjustment, upon x plus a into dx. Now here x square minus a square I can write as x minus a into x plus a, and remaining this plus a square as it is upon x plus a into dx. So simplify it. So I am getting I equal to a square by 4 log of 2a minus 1 by 4. So here integration 0 to a. Note that this part I will consider first. So here x by a, x plus a, by x plus a get cancelled. So it is a x minus a plus a square upon x plus a into dx. Now it is very simple to evaluate with respect to x. So I am getting I equal to a square by 4 log of 2a minus 1 by 4. What is the integration? It is a x square by 2 minus ax plus a square constant and integration of 1 upon x plus a. It is a log of x plus a. Lower limit 0, upper limit a. So put now there upper limit minus lower limit. So I replace by upper limit then lower limit remaining as it is. So minus 1 by 4 inside it is a square by 2 minus a it is a square plus a square log a plus a means 2a minus lower limit it is a 0 minus 0 because x is lower limit 0 plus a square log of 0 plus a means log a. Simplify, it will be your final answer. I equal to a square by 4 log of 2a minus, note that a square by 2 minus a square, it is a square by 2 but minus, and out of this it is a minus 1 by 4. So I will get here plus a square by 8 minus a square by 4 log of 2a, and this plus then minus and this minus, I will get plus 1 by 4 a square log a. So this cancel. So what I am getting? I equal to a square by 8 plus a square by 4 log a, which is your final answer. But one may common out here, a square by 8. So inside 1 plus 2 log a, which is your required answer.